I wanted to show you this one because there's a slightly different way we can do it. If we doodle a little picture, we got a spring, we hang a fish on the end, poor fish. Kind of like the suitcase question, gravity's pulling this thing down. The spring is pulling it back up. If it's just hanging there, it's a balanced forces situation. You can say that the gravity pulling the fish down is equal to the spring pulling the fish up, or mg is equal to ks. The way this question is worded, I don't care about the k of the spring. I want to know the mass of Mr. Zare's fish. We could just grind it out and do the equation twice. Use the numbers about the 3 kilogram fish, solve for the k, then use the k with the other s to find the other m. Or, if we're a little bit clever, what this equation really is saying is that it's linear. The mass is proportional to the stretch of the spring. When things are proportional like that, we can use ratios instead of having to do the equation twice. If we look at the ratio, how much farther Mr. Zare's fish stretched the spring compared to how far my fish stretched the spring, we can use that to figure out how heavy his fish is. We could call my fish fish 1, so it's something like 3 over, I don't know how heavy his fish is, equals 4 over 9. The ratio of 4 over 9 has got to be the same ratio as 3 to the second mass. 9 is 2 1/4 times bigger than 4, so his fish has to be 2 1/4 times heavier than the first one. Or if we just cross multiply, m2 is going to be equal to 3 times 9 all over 4. That second fish must be 6.75 kilograms. It wouldn't be wrong to do it the other way, to crank out a k, then use the k with the new s to find the new m. I just wanted to show you and remind you that sometimes ratios are a cool and sometimes easier tool to use